In the last 2 years, since we expanded our factory here, we've increased our volumes. We've quadrupled them, to be honest. We've kept it quiet that we've been expanding so much, and just basically selling it out into the market and improving the product gradually, month on month. As you've seen, with the addition of new laminators, new extrusion lines, we've not been out driving the market and to buy from us. We've just been sitting back in a lot of cases and waiting for people to come on. Our product has got better processing capabilities. It's obviously English made. Many people are coming to us purely to support made in Britain products, as well as for its technical attributes that have made it superior to other bars on the market. Such as the fact we've designed a spacer bar bending machine to process it, which other machines have existed in the past, but they're very expensive and they don't work on the non-metallic warm edge spacers. Our product doesn't have any metal in it, and hence it's always going to be better than products including stainless steel. We only started selling these machines in November last year. We've already sold 5, and our customers that are using them are reporting, very high yields, hardly any waste whatsoever, and they're cutting out the price of corner keys. Everybody's looking to cut down costs. Corner keys, you use 4 in every frame. There's no way of using less if you want to make a frame, unless you bend the frame. And that takes us on to a product then that's more efficient than any other method of manufacturing. It's a low cost, highly efficient manufacturing process on that basis. In terms of meterage into the marketplace, we've seen us go from 0 to approaching 50 million metres total spacer bar into the marketplace, with over 30 million metres of thermobar being sold in the UK market. And now with the expansion that we've put in place, we're looking to double that by going into the German market, the French market, Italian market, you name it, we're going for it. Well, we actually started Thermoflex before Thermobar, but it was a lot harder than we thought. It's caused us to invest large scale in an innovation centre to check the product. We didn't realise when we first started how in depth we needed to go. So we've ended up analysing the rubber down to the bare bones and working back up to get a product competitive with what's already on the market and the new competitors that are starting up all around the world. So we're now on the second phase of Thermoflex. Initially we manufactured it in EPDM rubber, but with the onset of IFT testing spacers for their conductivity and happened to be on the Bundesverband Flat Glass website, we decided to switch to silicon rubber, which has a lower conductivity value. Now, cost-wise, silicon is more expensive. To get that down to the price of EPDM products, we invested in a complete compounding line, which obviously you just saw. Now that involves us getting all the raw materials from around the world, mix into our own formula to make the base rubber, which we then extrude, which is where our current competitors start the process. They don't compound the rubber, hence they have a higher cost and they have to charge more money for silicon. So we're entering the market with a lower conductivity product, higher quality product at the same price as what they can currently buy in EPDM, which in the European market everybody uses silicon. In America most people use silicon. This is really the only market we can find where EPDM, which is a cheap alternative, is being used. So we feel the way forward is to offer a higher quality product at that lower price. That means we don't have to carry 2, an inferior and a superior. We're just going straight in with a superior product, giving our customers in the UK just the best choice. Well, when we first decided to make spacers, we decided we need to take it down to a chemistry level. The only way we could do that was getting involved with some proper scientists, as opposed to us who are a bit of it's a hobby, messing about with chemicals. So we did a deal with a UK university where we got a grant and support and the use of all their facilities to compound our own rubbers and our own plastics. So we had a guy for 2 years from university, and he stationed here and at the university. Now, obviously he's got loads of kit at the university, and when he was here, he didn't have loads of kit. So it became apparent that ongoing we needed that kit. We needed high-tech testing equipment, mixing equipment, computers to test everything to ensure that our product from the bones upwards was the quality product. So apart from just going to a university, making it and then hoping it's the same as what we made at that university. We decided to start investing 5-6 years ago in that equipment. So what you've seen today is 6 years worth of investment in terms of, right, we've got a mixer, now we need something to check it's mixed correctly. We've analysed the product, we need to check if there's any volatiles in that product. So rather than just test for the UK standard, we looked around the world and found that there were other higher standards. So we then bought the equipment to test those higher standards, so that any market we enter, we've already pre-tested it to their standard, and we won't get any nasty shocks or surprises when somebody goes, oh, you failed. Rather than do that, we test it first. So as you've seen, we've got EN1279 cabinets. We can test a new product from start to finish, made with all the same materials that our customers use, to the same specific, everything exactly the same. Test it and decide whether it works or not. Throw it away or then offer it to the customer. So then we go to a customer, they do a trial. They come back with the same response as us. It either works or it doesn't work. Things such as with Thermoflex, testing that the moisture capacity of the product is in it when it arrives at the customer. We don't want to take any chances on that, so we invested in a Carl Fisher. This tests exactly how much moisture is already in the product before it leaves our factory. And as I discussed with yourself, we keep a sample. In 10 years' time, turn on the computer, give us a batch number, and we'll be able to tell you the day it left, how much moisture was in it. We've got a UV box. Customers out there say, oh, certain competitors say your product will crack, it will blister. That's one of the reasons we went to silicon over EPDM. It cannot do that. We test for 3,000 hours under strong UV light to industry standards within the car trade. Everybody knows they test to destruction, and that's what we've done. We know it will not crack or blister, change colour, change its physical properties in 20 years' time. We've given a guarantee of 20 years on that because we've tested it ourselves in-house. The same with the components of the volatiles. As I've just discussed, we use a UV box to check for volatiles, but we also have a mass spectrometer. We can put the product into that at any point in the process, and it will tell us exactly how much volatiles are there or not, as the case may be. There needs to be none, hence we keep the records. It's there for all to see. We quite like it when customers, the press, come so we can show it off. We want everybody to understand that we're going for we're not just entering the market, we want to enter at the top and stay at the top.